Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
Morning. Everybody can hear me? Excellent. It's designing beautiful software, not necessarily slides, so bear with me. It's great to be back here at DPC. I didn't get to come last year. I didn't want to travel on my birthday yet again, so it's nice to be back. This guy, a couple, 2 or 3 years ago, they did all these nice things at DPC for all the speakers. We all got a little logo. So I'm project lead at Zen Framework. I have been for the last 4 years. I've been working on Zen Framework since 2006. I've been doing PHP code for a lot longer, though. I've been doing PHP for 12, 13 years now. I love open source software. If you want to see the stuff I'm interested in, mup.net is a good place. And my Twitter handle is WeiroFinney. Notice the second E in there. A lot of people forget that. We're at DPC, and actually a lot of my thoughts about this particular talk go back about 4 years ago. How many of you were here that year? Okay, do you remember who the keynote was? One of them, at least. There were 2 of them. Marco Tabini was there, and the other one was anybody? Okay, it's this guy, Terry Che. Did a nice obscenity-laden talk. It's great, actually. It's a lot of fun. But it got me thinking a lot. And one of the things he talked about was, when you're building things, you've got all these language purists. They're saying, "Oh, my language is better than yours." And you've got the Ruby's saying, "Oh, we can do things so much more elegantly." And Python's like, "Well, it's all about the white space, man." And Terry says, "Well, PHP is like a ball of nails. You throw it at something and it just sticks." And everybody's like cheering. This is great. This is fantastic. And I've been thinking about this for 4 years, and I hate this analogy. And the reason being, has anybody here ever done any construction work of any sort? No? Okay. I have. So anyway, you go and, if you got a ball of nails, you need to build around it or modify that area of the house. You're going to bleed, and it's no good. And I started thinking about this in terms of an analogy for software, and a ball of nails is exactly what we don't want. We don't want to be avoiding something because we know it's going to hurt us. I thought I turned off this. There we go. I don't want to be, if I have to modify that, I don't want to be working around it because I'm afraid of getting hurt. I don't want to be figuring out, okay, what sort of gloves, how thick do they need to be so I can pry this out. I don't want to be doing that. And with software, it's the same way. I want the software, when I come back to it, to be something that I feel comfortable working on. And so we're going to be talking a little bit today about beauty. Little known fact, I actually don't have a degree in computer science. I started in computer science, and then I took a course in artificial intelligence, and we were talking one day about whether or not it was ethical to turn off an artificial intelligence. Theoretically, nobody's actually made a true thinking machine. But we were talking about it, and it's like, well, no, it's just thinking, and it's not really thinking. It's it's using logical-based processes, but it's not the same because I get hungry, and that affects my thinking, right? So I ended up in the religion department, and we actually did a lot of stuff about philosophy and stuff like that. And now I'm programming again. Who knows who this is? So Plato. So kind of father of Western philosophy. How many of you read any Plato at all? A few hands going up, right? I was really, I was shocked when I first read Plato. It was actually eminently approachable. And one of the things he talks about a lot is the idea of the good, or the idea of beauty. The Phaedo, he talks about beauty, and the Republic, he talks about the good. And he does some tremendous things about questioning and rolling down this thing, trying to understand the problem. And I'm actually going to be using this as an analogy. We're not going to talk about Plato or Socrates, but I'm going to kind of use the Socratic method. We're going to keep saying, does it accomplish what we want? So today, we're going to talk about beautiful software. And it might look pretty like this or it might not. But this is what I'm really wanting to look at today is what constitutes beautiful software. And really, I think there's a lot of different ways of having beautiful software. There's a sparsity that can be just incredibly elegant, but there are other times when we need to look at different things. That intro about who I was, I work on Zen Framework. I get informed by people who are building long-term large software projects, which are going to be very different than a quick client project or a mock-up for some sort of startup that you might be doing. But my software design aesthetics are informed by this, and so you may or may not agree as we go through. Basically, I feel that as we are developers, we evolve as we go. We start off, learning a little bit about, functional logic and perhaps branching and that sort of stuff. We move on to loops and actually doing functions, and hopefully we get even further as we go. And what I'm hoping is that as we go through this talk, we see the evolution of a piece of code. And it may have looked like a very simple problem when we start, and it'll look very complex perhaps by the time we get done. But the hope is that you can see how we keep asking these questions as we are working on the code, how we can make it something that is beautiful in the end. So the Socratic Method, we're going to keep questioning, see if we can ferret out some truths, and see what we can do from there. The real-world problem I came up with is dead simple. We have an application that needs to send email. And I know the sender is always the same. I know that I want to BC another address for verification. So you, my dear sir, I love you. Andre's bringing me coffee. I haven't had any yet. Thank you. Excellent. Thanks. Yeah. Yeah. Coffee always helps write beautiful software. So, dead simple problem. I used to work at a nonprofit, and we actually had a number of mailing lists, but there was also a store associated with this, and this was something that we did. And it was actually my first, one of the first things I had to do going into this organization is we had two different sites. We had a mailing thing that happened on both sites, and we needed to do that and add the mailing to the other site. And so I went and did this, and it's like I basically cut and pasted code and changed a couple lines, and I hated it. And so we started looking at what we could do differently. So the code looked a little bit like this. So we have this function. We're going to send a mail to subject body. It's hard-coded in there. We're using mail. We'll just use whatever is configured on the server. Everything's good, right? So this is actually a fairly simple piece of code. And we're wrapping it in a function simply so that we don't have to, have the from and the BCC in there every single time. So, question: is it beautiful? It's succinct, right? Gets the job done, right? It prevents us having to specify the headers manually on each call, right? So it saves us some code and a little bit of duplication. But in the end, it's really just a little more than a wraparound mail, right? It's just a proxy class, or a proxy function. So what if we introduce some new requirements? So, like I said before, I go into this organization. We already had this mail function, but now we need to do it for another portion, another domain that we own. So, like I said, we could copy and paste and stuff. Great. But the big thing, though, is that the from and the BCC are going to change at this point. So we need to change that stuff. So we have a new problem. We don't necessarily want to change all the places in our code that this is going to be called from. And at least, especially not after this change happens. So let's introduce a configuration parameter to this. So we have the simple function wrapper around mail, but now we'll have a configuration parameter so that we can actually do something. So what does that look like typically? We've got a configuration, so now what do we do within the function? We go and do a switch statement, right? And so Douglas Crockford, being good people here, we're going to do breaks, right, so that we don't fall through. And we have here the, we have our subdomain, we have our original. So we have the case and the default. So we actually do fall through on the case. We have our original and the subdomain, and we can go and now have different headers. And otherwise, 15 through 17 are exactly what we had before. But now we're using variables in there. So We've got new code, slightly longer. It's getting a little bit more unwieldy, but it's, it does it. Is it beautiful? I don't know. Switch statements, some people hate them, some people love them. The fact, though, is that as we add more subdomains, it means that we're going to have to touch this code, right? We're going to have to add another case statement every single time. And if we go back to the code itself, you'll notice we have that last argument, that shop argument. There's no easy way to know what that argument's supposed to be. So we're going to have to know that we have to pass it, and we have to know what the different values are. And so we may want to do things a little bit differently. And really, when it comes down to it, the number of arguments is still not giving us a good justification for wrapping mail at this point. So what's the next evolution? We're using a function. What do we do next? Somebody? Anybody? Yes, make a class. So when we start talking about extending something or configuring state, we inevitably end up somewhere with object-oriented programming, right? So we're going to go do that one. It looks like I have a bad break in here. We're just going to keep going. Went through these earlier and I missed that one. I missed a couple of things. My slides are bad. So we're going to use a class. So sorry about this. I went through and I was going through all the slides. I fixed all the images, and evidently this one is broken. So we have a class here. And so the class we can set, we're going to, in this particular case that I was going to do, I was going to use late static binding. So we're going to have a static member in there telling us which one we use. And so we can extend and simply change that static member and do things. So extend and modify. It's dirt simple. And in fact, with PHP 5.4, I could then simply call the class and instantiate the class and simply call it as an invocable, and we're good to go. Is it beautiful? So we're now looking at classes and objects, and people are like, woohoo, yay, we've got object-oriented programming. Great. The problem, though, is that it actually requires extension. So you need to know what the classes are, and you end up having this proliferation of classes. And if you don't believe me, go look at Zen Framework, because that's what's happened. You end up extending. And we have problems when you extend, because then if you want to add other behavior, you get issues. Because you're using static members, you have to have some sort of knowledge of the environment. So if you want to choose which mailer to use, you're probably going to need to know what environment am I in so that I know which class to instantiate. So now you start introducing things like factories and all that stuff. It gets a little bit much. And the debugging is also going to require some knowledge of the environment. So we have to know what environment we're in so that we can figure out what mailer is happening and what headers are going to be set. So the next thing that we can do is the exact same thing that we did when we were using a function. Let's introduce some configuration instead. So in this case, what I'm going to do is simply have a config as an array of objects so that we can go in and say, hey, let's set the environment to a certain subdomain, and then we can go and do our mailer, and we'll use call user func in order to select our mailer and everything, so we're good to go. So the idea that I had was I had two different mailers. I had the original mail and then the subdomain mail, and then the send method goes. So now we can do it using a configuration. I would argue it's probably easier to just indicate the class to use and have it the same throughout. But the other thing is, what if we need another requirement? Now we have more configuration, and really the class didn't do it in the first place. So now we want to do some more. Really what we're talking about at this point, we're not actually talking about object-oriented programming. We're talking class-based programming. Object-oriented programming, we have instances, and we actually call methods on them. It's not really when we were looking at was static method calls. It's just namespace methods. Functions really is what it comes down to. So let's actually look at object-oriented programming now. So here's a good example. Well, better example than we had. So we have a mailer class, and we have some protected members for from BC, the content type. So now with that content type, we've introduced, we have that new requirement. We can capture it as a member of the class. Great. And then when we send, we can figure out how we want to send the content. But having that content type means that we can also specify yet another header. So this is good. We've now got an additional header. Usage is kind of pretty. We're introducing more code, obviously. This is more code than what we had before, right? Before we started off with like 5 lines, and now we've exploded this to at least 18. But if you actually expand all those methods, it's going to be quite a bit more. But the usage in our actual code is we simply instantiate that class, call a few setters, and then we send. So this is actually starting to look pretty nice. And we can read this. It's good. So what do you guys think? Is it beautiful? It's better. It's not great. Our headers are still hard-coded, right? Does anybody here know how many header types there are in the mail specification? Yeah. And really it's infinite because you can also do the X vendor namespaces, and you can do as many as you want, right? So this is not great. And the other thing is, what if we don't want to use mail? What does mail do in PHP? Somebody? Right. Reps send mail, except on what platform? Right. So on Windows it doesn't. It does something else, and it's kind of magical, mystical, and everywhere else it does send mail, which might be send mail, it might be Xim, it might be postfix. There's all sorts of things. So it might not even be configured correctly, but the other thing is that's local to your machine, right? Do you really want to be sending stuff from every server you have out there? It's a really good way to get blacklisted on spam servers, right? So we don't want to do that. So I'd argue at this point we won't need to kind of scrap things here for a little bit and take a shower. If you do agile practices, this is something that comes up. If you don't feel you can start coding right now, then go take a shower, go take a break, do something else. And I argue you should be doing this with your code all the time. Just sit back, take a look at your code, and say, okay, I need to walk away for a little bit and figure things out. So let's think about things. We've identified a couple of needs already. Arbitrary headers, right? We added a content type header. Who knows how many other headers we're going to want to do. We may even want to put in some sort of tracking headers, right? And then we also identified that we may need arbitrary transports. So, send mail may be great, but ideally we're wanting to communicate with our company's mail server so that all the mail is going out of one place, and we stay off of all of those bad blacklists and all. So we'll probably talk SMTP, right? Or we might talk to a queue, and the queue runner over on the other web server will go and send those mails for us. So, next evolution. We've talked a little bit about classes. They've helped us with states. They've helped us, be able to do configuration because we now are using actual instances. But let's evolve a little bit more. We'll use composition and interfaces. So composition, my friend and colleague Ralph Schindler, he calls it the Hollywood principle. I'll call you, you won't call me, right? So we pass in the object into the one object into another, and it calls on it. That's it. So instead of us, trying to, just statically grab it, or like as we do in procedural programming, you just call a function, we're going to actually pass these objects in. So here we have an interface for mail transport, which is simply, we're going to send something. And we have our headers. And so doing our headers this way, as an array object, means that we can add as many headers as we want. It's not a great example, but it captures the idea here. So toString, we loop through those, and we use the key as the name of the header, and then we separate everything out. So we're able to do a little bit more. Then our mailer can compose a couple of things here. So the mailer can have the headers and a transport. So we set the headers, and then we can actually get our headers, and we can set the transport, and then we can do some work. Okay? And the work will look a little like this. So our constructor will get our mail transport. We'll set those things, and then when we send, we're going to send to the transport, and we'll pass in the headers and everything that we need. It's looking a lot more complex. But what we're able to accomplish is a lot more than we did before, right? We don't have to go in and touch a whole bunch of code anytime we want to add a header, for instance. We just add a header. If we want to change the transport, we go and implement that interface, and we change the transport. So it's looking a lot better. And really, when we go to our code, that's starting to look better as well. So we can have our config object that's kind of specific to our environment, and we can pull values from that, and we can then set those headers, and we can send to the transport, and we're really starting to look a little bit better, more flexible, right? The idea here is, when you are working on code, how often does the spec actually stay the same from day to day, right? How many of you have had a spec stay the same from the time it was signed off until you actually delivered? Right? None of us, right? It doesn't happen. So we need to start thinking about ahead as we do our coding. We need to be defensive driving with our coding as it may. Is it beautiful? We're getting there. I think we're getting there. Our header management and the serialization is self-contained at this point. This is good. We can, because the reason for that being self-contained means that we can do arbitrary headers. This is great. I like that. Another thing that's good about it is the sending is now separate from the message composition. We can actually have a separate transport that sends this stuff. I'm liking that. But there's a big question. Did anybody spot a flaw with that last example with the mailers? Stefan Hochdorfer is here. I'm sure he's probably shaking his head. Yeah, there's a problem. And the question is, semantically, should the message be sending itself? Or should a transport be sending a message? Right? So it's not just about having the composition and everything. Yeah, that's great. We can test each of these individually. That's fantastic. But figuring out how they actually need to relate to each other. So we look at object relations. Basically, each object should do one thing and do it well. And if you start doing this, you'll notice that your objects tend to get smaller and smaller. And you also get a whole lot more of them than you ever thought you were going to use. But the point is that your objects are now acting as messages between other objects. And you have this you have this stateful behavior that you can pass around. And there you have published interfaces that are very easy for people to adapt to. So let's look at this a little bit more. So if we think about the message not sending itself, we can start thinking of the message as a value object, right? When we look at mail, we've got headers and we've got content. And there are a few common headers that we probably want to be able to address, the to, the from, the body. So we want to be able to do those. And so we will probably have some proxy methods and all. But really when it comes down to it is we should be able to set arbitrary headers and a few other things in there right off the bat. You'll notice that we are composing. We're using the same things that we've learned already. We've learned composition of our objects, and we're going to utilize that because the mail message composes headers. It composes content. So that's what we're going to be doing. The headers and the transport, we're going to do slightly differently. With the headers before, we were simply doing an array object, but the problem is that doesn't allow us to validate properly. If we're doing this right, we probably don't want to send invalid headers, and we don't want to be sending, like for instance, numerical headers. That's a bad idea. So we want to do this in a better way, and we also want to have the serialization captured as well. So we'll do an interface for that. So we'll have add header, and we have the header name and the value and the string. This gives us a nice succinct interface that's easily to understand. The transport remains the same, except for instead of taking to, from, body, and all that stuff, we're going to take a mail message because that has everything that encapsulates a message. So when we get to the usage, we're getting a little bit more verbose. The original example was, 5 lines, right? So we've got a little bit more, but let's take a look at it. We instantiate a message. We instantiate some headers. We add a couple of headers. Add some stuff to the message. And then we take our transport, we instantiate that, and we give it some configuration so we can actually set it up. So that might include, the server it's going to, the port to use, all that stuff. And then we take our transport and we send the message. What's interesting about this is it starts being readable English or readable natural language. Transport send message. It's a command. I can do that. So, is it beautiful? Well, it's getting better. So our headers can now potentially have validation and normalization. Before we were using an array object, so we would have had to munge a little bit in a couple of different places to add that. Now we can do it in that single method. You add headers that way, that's it. That's good. And the other nice part is that we can vary the implementation. So if we want to do things slightly differently, we can. We can implement that interface and do something differently. The message is now self-contained, and it contains all the metadata related to it. That's good. It's a value object. I like this. This is looking good. And the mail transport is now accepting the message and sending it. So we have something acting on another object. So I think we're getting there. It's looking good. What are we really asking when we're asking, is the code beautiful? How many of you were at the keynote today? It's probably most of us, right? Yeah. As he said, and I'm a strong believer in this. I've talked to a number of people. Paul Jones, who's heading the FIG stuff, he and I have had discussions over this a lot of times. Yes, we're coding for computers. I've got that. Computer ultimately needs to be able to parse it and do something with it. But the other part is coding for humans to be able to read it and maintain it. So let's ask what we think is really being asked. When I'm asking, is it beautiful? The first thing I'm asking is, can I maintain this long term? How many of you have projects that have existed for 1 or 2 or 3 or more years? It's a lot of us, right? None of us like looking at our code 6 months later either, right? So the thing, though, is if the code is something that I feel comfortable maintaining, I would say that it falls into our idea of beauty here. Why? It allows us to do things like substitution. Why is that important? Testing. If I can mock that object, I can test this other object that composes it and not be worrying about, all the different relations and everything. It's just whether or not this one works. And I put in a substitution that can mock some behavior and do everything. That's great. I like testing. I like testing because I can, throw my project up on GitHub, have a little bit of configuration in there, and Travis CI starts emailing me and telling me things are broken or things are fixed. This is great. If it's broken, I go and I look, what broke? Try and fix it. Everything's fantastic. The other thing that I think we're really asking here with software when we say, is it beautiful, is can I change the behavior when needed? So in our very first example, it was a small little function, but you can't change it because if you change it, you're introducing the potential for another bug. So a good solution is going to allow for substitution. A good solution is going to allow me to create new implementations. These are things I'm going to look for in code to say whether or not it's beautiful, whether or not it's ready for me to actually start using. So these are the principles that I'm really looking at and really asking about with it when I say, is it beautiful? Can I do those two things? Is it maintainable, and can I change it? So there's a lot of ideas around this. First one is, of course, solid. How many of you have seen this one? Solid? Yeah, a lot of us. I'm not going to try and rattle off the things, but the idea here is that you're going to be looking at separations of concerns. You're going to be looking at the law of Demeter and making sure that you're not calling objects that are nested where you don't know the behavior. You're going to make sure that you have inversion of control so that the dependencies are injected. That's composition. There's all sorts of things that solid can teach us. If you don't know this one, look it up on Wikipedia. You'll go down a nice rabbit warren of articles. It's fantastic. Another idea to investigate. How many of you have heard of aspect-oriented programming? Quite a few of you. It's not as common in PHP simply because we can't compile and inject this stuff. But the idea with it is that with these principles, I can provide inflection points within my code so that if I need to alter the behavior or inspect the behavior, I can do so easily. Event systems are a really nice way of doing that. You trigger an event and you can have listeners or not. And if that listener is there, you can do something with it. So I can introduce cross-cutting concerns like logging or caching or something like that. Or I can do things that might alter the execution flow, like short-circuiting the execution flow and do some other things. So aspect-oriented programming, event-driven programming are things that are very interesting. If you haven't investigated the Lithium framework, they have a really interesting take on this using something as simple as closures. And we all know how to do closures. It can become a huge old mess, but it's also at the same time, it's really a nice breath of fresh air through the PHP community when you start looking at these ways that you can introduce inflection points in your code. Because the inflection points let us extend and change the behavior. And of course, testing. I love coming to DPC because when I ask how many people are testing, all of you are raising your hands, right? Yeah. No. Are you? Come on. You guys are disappointing me. One of the things I do frequently with the Zen Framework project, we have RFCs that we do, and the RFCs then define the specification that we want. And from there, I can say, okay, these are the behaviors that whatever I'm programming needs to obey. What's fantastic about that is I can take those requirements and translate them into tests and code. And with the tests, I can even say with the name, I can be explaining what the behavior is. So I want to test that given this particular input, I'm going to get this particular output. And then I can go in and start coding it. I actually constantly will go through and start playing with the API at that point. I haven't even written the code yet. Why? Because I want to see if is this some code, is this usage pattern going to work? Is it going to be something that somebody's going to be able to pick up and understand just by looking at it? So I can play with the API before I ever write it. So I'm saving myself effort, which is great. And then as I do this, I can be looking at it and get confidence that as I'm coding this stuff, it's going to work. And it's going to be something I'm confident that other people are going to be able to use and enjoy. The other part about this, though, is that as I'm doing this, I've captured everything in tests, and then I start programming to the tests. And, of course, you have to adapt. You start writing, and you go, oh, that's not going to work. And then you go back and you change things, and it's this back and forth. But as you're writing these tests and the code, now when you get done, you've tested the behaviors that you set out to do, which means that I can now use continuous integration and that sort of thing. So as I maintain it years down the line and somebody says, hey, I need this feature, once I put in that feature, my continuous integration runs and it comes back and says, hey, you broke. And I can go back and say, hey, you know what? That feature you wanted is in direct contradiction to the one that this project manager over here gave me. You guys need to hash it out, but I'm not going to do anything else right now until you tell me which one is right. So that's going to help you as a developer communicate to the people who are giving you those specifications in the first place. Another idea to investigate is coding standards, and this one is a minefield. But I hope that if you went and saw the keynote this morning, you'll see why it makes sense. Coding standards are not about whether I think it looks right or whether or not I agree with it. It's about having consistency throughout a whole body of code. Just do it. It saves you time. Your business is not writing a coding standard. Your business is getting some code out there and developing a product. Adopt a coding standard so that your whole team can look at the code and read it and understand it when you first start. Now, when you start looking at these principles, there's always trade-offs. You can always write shorter code. That first example that I had on there was perfectly fine and perfectly valid for the company I worked at until we had another subdomain. And that's when it fell apart. But it was fine. So you need to be thinking, figure out what is appropriate for the situation at hand, but also be keeping an eye out later and thinking about, is this something that we may want to reuse later? So the trade-off with shorter code is reuse. But the reason was that we couldn't configure it and we couldn't alter it without changing the behavior it already had. You end up writing the same code over and over. True story. With that example that we had, when we got that new subdomain, I went and simply copy and pasted it and changed the name so that I didn't have to worry about it conflicting. That's all we did. And I knew a little bit about object-oriented at the time, and I'd been playing with it in Perl. We'll not go there. But one day, there was just two of us. I had the IT lead and then myself, and he just threw over the desk one day. He's like, I think we should start using object-oriented programming. At which point it's like, yes. And so I went and took that example and I created a class. And it looked exactly like that first one that you didn't get to see, where you had a static method. And I just had different static methods that set the headers, and then we called another method that actually sent the mail. But the point was that we were rewriting the same code. And it really, when he said, let's go object-oriented, it was because we suddenly had our third subdomain, and we were going to have to do this another time. So trade-off with shorter code is reuse. The other next one, and this is one that is really interesting in the PHP community, is the trade-off, of course, for trying to think about extensibility, reusability, that sort of stuff, is that you almost always get verbosity. And there are so many people in the PHP community that, like, I just want to get shit done. This is too much. And the fact of the matter is that when you start doing this stuff, you end up with a proliferation of objects and files like you would not believe. I've heard some people say, if you have more than 10 or 12 lines in the call stack in PHP, you're doing it wrong. But it doesn't necessarily mean that's the case. What it means quite often is that you're actually trying to separate the concerns, and so you have a lot of objects. That's not necessarily a bad thing. In fact, I would say that you need to get over it if it's a problem. And I understand where people are coming from. They want to be able to just look at one file and figure out how the whole thing works. But as the application domain gets more and more complex, it's easier to break things into smaller chunks that I can then look at and understand and digest in smaller pieces. And then I can start looking at how they relate and interact. As I say, it's easier to digest a roast by eating it and chewing it and cutting it into small pieces than trying to consume it at once, right? So another trade-off, configuration is great. And it can be inline or from a container. And quite often the shortcut is, hey, let's just do it inline. We're using this configuration value. It's great, but it's difficult to swap out. If you need to change that later, it's a problem. Again, I want to be, if I can at all get away with it, I don't want to touch that code ever again. So container is a nice one, but you have a trade-off with a container for configuration as well. And that's that you now have to pass a container around. So it's an issue. So beautiful software, maintainability, reuse, extensibility. These are things I look at. Balls of nails get the job done. We're all here because we do PHP. And a lot of us chose PHP because we were able to get something done quickly, right? We were able to learn the language quickly, which is great. I think these are all great features of the language. My point is that when I'm thinking about a code base that is going to be around for years, I want a precision instrument. I don't want a ball of nails. I want to be able to go in and be able to fine-tune this easily and not be afraid of, losing a limb or something as I go. So the whole point here is I want to think about long-term maintainability, and I want to think about reusability as I'm doing stuff. And that's it. We're ending a little bit early. This is stuff I love to talk about. I've had numerous conversations this week. I've been at both IPC and DPC this week. I've talked to lots of people about software quality and design. Come see me at some point. I'll probably be down at the Zend booth or sitting at a table somewhere. If you want to talk about this stuff, come approach me. Of course, you can rate on Joined In, and feedback. I include the GitHub account because we're talking about code. So if you see something I'm doing that looks absolutely shitty, please send me a pull request. Thank you.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.